Hey everyone, my name's Shane. I am a college faculty currently. I've been in IT for about 10 years, like on and off, teaching, doing, going back and forth between those two things. And I really just like technology. So I've got like a little, this LLC entity. It's really not much of an entity at all. It's just, I work contracts occasionally, like for instance, it's summer break right now, so I'm not teaching college. And occasionally I like some extra money, so I'll work contracts for like Pearson and other training companies like Stormwind here in the Scottsdale area of Arizona. Published a book last year for Pearson. It was actually for Cisco Press. It was a Cisco Press book, and enjoy doing just projects like these. So this is actually my first video that I'm just doing on my own accord for myself or for no other reason than I find it interesting or I think it might be helpful. And we are going to, in this video, look at complex, not the highly complex regular expression syntax, but complex as in a lot of syntax. Like, how do you work with these long regular expressions, or how do I work with it at least? And I don't know. I'm not Mr. Unix guru with the beard and the ponytail, but they're bald. But I'm getting there. I think I'll go bald soon enough, and then I'll finally have street cred. Let's look at this. What am I even doing first off? Well, let me jump over to our demo environment, which is really just the same computer. And I've got my hair down, so I'm sufficiently unprofessional. Like I'm hip, right? I think that's how that works. And let's look here. So what I'm doing, first off, what I'm trying to accomplish, what I am trying to accomplish is I'm making a dictionary of IT terms because I've got a script. I haven't decided on a name yet, but it's a script that uses Whisper AI, so it's an OpenAI model to transcribe just audio, right? From video, from waves, it could be audio or video. It extracts it out, or we can extract it out with FFmpeg and then transcribe it. And then in my case, I want to convert it to SRT and VTT files, which are subtitle files for lessons like this. And I'm getting pretty good accuracy now by introducing prompts and prompting it properly, but I still think I can do better with post-processing. So what I'm trying to do is build a dictionary of IT terms that I can use in a few different ways. For instance, giving it to an LLM like Claude or Gemini or ChatGPT for post-processing, for like basically doing, I guess, editing, right? Revising the transcripts to make sure they're nice and accurate. Because it still makes some silly mistakes running the model locally. So that's what I'm trying to do. I'm just getting a dictionary, really in this case, of acronyms is what I'm after, because the acronyms seem to be a big sticking point for Whisper. That's sort of the motivation here. And I've got some tabs open. There's lots of sources of acronyms. You could go to NIST has a glossary with tons of acronyms. So does CISA. Those are both cybersecurity related. Other sources, a good one is actually CompTIA. So and that's what we're going to use here. We've got, nope, I opened the wrong tab group. We've got these CompTIA exam objectives. At the end of all CompTIA exam objectives, they've got a glossary or a list of all the different acronyms and terms. So that's what we're going to use. We're going to copy paste that into a text editor, this one right here, and we're going to go through, kind of clean it up manually a little bit, just enough so that we can use regular expressions. And then having done that, we'll build out the regular expressions to extract the acronyms so that I can then use it for post-processing using LLMs, using other like Python utilities like, what is it, PyLanguage tool or something? And there's a few other spell checkers that you can use. There's a lot of options. So let's do this. Let's do this. Let me clear the screen up a bit. And why don't I'm going to stay on this side of the screen, but let me try to arrange a little bit all this busyness going on. And behind me, there's GNS3. I'm demonstrating Hydra for a pen test class that I'm teaching. All right, let's do this. So we have these. This is like the A+ exam objectives. You can see on this on the left-hand side. I know left from right. And these are what I want. I want these acronyms, and I want just the acronyms. I don't want the rest of this. Now, there's a few issues. First off, they have different patterns, text patterns, uppercase, lowercase, special characters, spaces, numbers. Like, so we have to account for a variety of different patterns. That's the first thing I'm always looking for if I'm trying to extract any sort of text from a document. What are the patterns I'm seeing? So I'm seeing uppercase, all uppercase, different numbers of uppercase characters. Some start with a lowercase character, but the rest is uppercase. Some will end with a lowercase character. Some will start with uppercase letters, but end with numbers. And there are some other variants in here too, like some, and I'm sorry it's so small. Let me zoom in so you can see this. Some will have just a lowercase character in the middle, or two. If we look for platform as a service, I'm not sure if that's in this exam objectives. Not pass, but we want PAAS, yeah, pass. So you can see that that's got two lowercase characters bounded by two uppercase characters. So there's different patterns that we want to look for. And well, first thing, let's just get this all over into text documents. And there will absolutely be duplications because we're going to copy all these exam objective glossaries. It's going to duplicate a lot. There's a lot of overlap between the terms used in CompTIA exams. But luckily, it's very, very easy to deduplicate. So I could just, and actually, maybe I will. I'm just going to copy like this. Should I do it like that, or do I want to keep it nice? I'm going to keep it nice and clean. Let me show you. Let me make this a little bit larger, and then we'll zoom in. So one way you can copy, and it's still not going to copy perfectly, is if you select like the beginning of what you want to copy. Scroll down, you can hold the shift key, double click the end. Well, if you triple click, it's going to break it, but there we go. That's a nice copy. That's clean. I don't have this acronym here. I did miss an A, so I need to fix that. Let me fix that. And you can already see there's issues. We zoom in. There's like certain things are going over to the next line because we're copying from this PDF. For whatever reason, copying from these CompTIA documents is always a pain. I don't know. I'm not a PDF surgeon. I don't know. Let's continue. We'll just do the next page. I'm just going to run through in the same manner, selecting everything I can that isn't sort of junk. And if you miss a character, you can use, if you're holding the shift key, you can use, left and right keys to highlight another, or deselect, I should say, another, depending on which direction you're going, another character. Did I get them all? I think I did. I'm gonna do Control C. I'm gonna go down to the bottom. Oh, jeez. Stop helping, macOS. Jeez. Oh my gosh, macOS. Stop helping. Please, you aren't helping. All right. Copy paste. I know this is thrilling stuff. I'm gonna get through it as quickly as possible. Paste, and we're gonna do this, and we'll do this one. Maybe I should have just copied the whole thing and cleaned it up afterward, but this will actually save us time in the long run. Usually it's gonna save you time to get cleaner information in than the like dirtier information, because it's just more to have to clean out. You might have to make regular expressions to account for information that you could have just avoided copying in the first place. So my recommendation is to keep it clean if possible. The data anyway. I'm not gonna weigh in on other things, and let's finish this out. Did I already get this or what? Cross-site scripting, I feel like I see that a lot, but then again, like I said, there are lots of overlaps. Okay, we've got, that was the two A+ exams. Let's do I'm gonna skip the address record. I feel like that's not gonna add much, just the single letter A. And let's do this. Go back. Control C. So we still have acronym. We're still highlighting at least one of these, the acronym, and spelled out here. So we'll need to search for that and remove it. I want to clean it up before we even start using regular expressions. Maybe I'll probably go back and edit this after the fact, so you don't have to watch this whole thing. This whole thing of me just copy pasting. I know it's thrilling stuff, but I might just spare you that. And let me do this. And we'll grab dir, distinguished encoding rules. It's a classic. Oh yeah, we're getting lots of acronyms. This is gonna be good. My model is gonna devour this. Not really. We're not even training it. I don't even think, can you train it? I'm not sure you really can tweak it very much, but the post-processing will be significantly enhanced. It does things like, I say CPU, it thinks I said CU, and it thinks, it just makes some strange errors like that. So it'll be good to have all these acronyms in a nice post-processing dictionary that I can either do with a Python library, and probably will to start, or I could send it up via API calls to any of the big AI models your ChatGPTs, your Geminis, your Claudes, they're all capable of doing the post-processing pretty well. And we have Cloud Plus. So I just tried to pick a variety. I did the A Plus, the Network Plus, the Security Plus, and then Cloud Plus and Server Plus. And the reason I wanted variety was, well, I mean, who knows? Who knows what class I'm going to teach, right? It's actually very difficult for me to predict that. So we will just assume that I can teach anything and everything, or that I might have to. And so variety is good in that case. And here we go. We're just about done. I'm definitely going to cut this a little bit at least. I don't think 5 minutes of copy paste content is super thrilling. All right, we got it all here. A few things we need to do. We need to clean up this data first. I'm going to make it nice and large. Now that we've finished the copy paste, let's zoom in. Let's see what we can do. First off, search for acronym. So we want to get rid of these because that is not adding anything. Acronym. Get rid of that. And let's do next. Get rid of that. Notice that like it did wrap like unnecessarily in certain situations like this TCP/IP. So where I see that, I'm going to fix it. Although it doesn't really matter because we're just after the acronyms. Still, I like to clean it up where possible. The more consistent it is, the easier it is to work with. Notice, yeah, we've got duplications for sure. I'm sure that they're working from a common set of terms, topics. And are we just about done? We should have just done a find replace. What do you think? Might have made a little bit more sense. Acronym ooh, this one's uppercase. Cool. All right, get rid of that. And we're just about there. Find replace would have made sense. But then again, they are using different terms for these different exam objectives. Spelled out, definition. So I don't know. Maybe it wouldn't have been better. Cool. All right, that is step one. Sorry to scroll so fast. Step two, I just want to clean up these lines. I'd like to, as much as possible, keep these, and it doesn't really matter, like we can work around it, but as much as possible, I'd like to keep each acronym at the beginning of the lines because it's going to be easier to write the regular expressions. So ARM, Advanced Risk Machine, this is another thing that CompTIA did that we should probably search for, is when there's an acronym within an acronym like this, they enclose it in these square brackets. And that is just like more things that we have to account for. So Advanced Risk Machine is ARM, and then risk is reduced instruction set computer. So I'm just going to split those out onto a new line, and we'll search for it. We'll do all of these. Transmission, no, TCP/IP we don't need to add. That's already defined. So it's kind of redundant that they include that. Small computer, I think they do include yeah. So they've already included SCSI, so we can get rid of that. And it's manual, and like the whole point of regular expressions and scripting is that we can avoid manual work, but sometimes it just makes sense to clean it up beforehand because it's going to save you so much time with the like the devising of regular expressions or your scripts or whatever. All right, another unnecessary expansion of LAN and reduced instruction set computer. Continuing. All right, they've defined GUID. It's right here. Why would you define it again? Whatever, I'm not going to judge. All right, so GPT is GUID partition table. All right, and on we go. If there's many more, I'm just gonna call it quits. And we can actually just write it like a regular expression to match on anything between these brackets. I just personally like to clean it up as much as possible. All right, we're just about there, I think. I'm saying that, I actually don't know. I have no idea if we're just about there. I'm committed now. It's like a sunk cost fallacy, right? Okay. Next bracket, please. Are we out of brackets? Good, good. Oh, we aren't out of brackets, but we are just about out of brackets. Cool. All right, I'm gonna save this. We'll save it in dictionary in progress, and this is going to be CompTIA kinda clean .txt. So it's kinda clean. We kind of cleaned it up, and now we've got this text file to work from. All right. So line overruns. I think we've got most of the line overruns, and I apologize for scrolling so fast. I'm just gonna double check. That would be like this. If I demark, where was demark? Here. It's just because we copy pasted from a PDF. So demark was one, and smart technology, that's your kind of drive self-monitoring technology, TACAX, which is missing the plus, that's fine, whatever. Yeah, that's probably, yeah, DOH. All right, that's clean enough. Get rid of like spaces that are there. That'll do. That'll do. That's looking pretty good to me. It's looking pretty good. Let's go to the Z shell in this case, a shell in any case, and let's clear this and start thinking. Okay, I'm gonna do plus 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 plus. So we've got a few patterns, and I'm gonna make a new. We'll save this, and then what I'm gonna do is make a new text document because I want to keep my thoughts straight. So we've got a few patterns that we saw, and one of them was the windowing system in macOS is a little wonky. One of them was just like all capital characters, with smart being the one that had like periods. So we could match on that. That would be one regular expression. That would be, let's say we make a regular expression for this. Make it nice and large for you. Come on, you can get bigger faster than that. Let's say it's the beginning of the line, so that's what the caret means. It means starting at the very beginning of the line, we want to match on uppercase characters. So we could say A through Z, capital. So that's going to match on a single character that is uppercase, A through Z. No numbers or anything like that, no special characters. And then we can add additional things that could match on in that position. And the first would be a period. So we do backslash period. A period is like it's a syntax character with regular expressions, so with grep and other tools like that. So it matches on any single character, any single character. So we don't want it to match on any single character. We want it to match on a period in this case. It's not syntax, it's an actual literal period. So we use the backslash to escape it. So we're now matching on A through Z, capital letters, or a period. And then the other thing that we might want to match on is a dash. Yeah, let's do a dash. There's certain terms are going to just have a dash in them. So we'll match on that as well. And also let's do a forward slash. A forward slash would be like TCP/IP. So if I'm just gonna write out some of the things this matches on. So this would match on radius, or it will when we're done with it. It will match on smart, and it will also match on TCP/IP, or at least that's the goal. These types of terms. All uppercase, potentially with some not syntax characters, but some punctuation. But this only matches on one character, so it can be an A through a Z, a period, a forward slash, or a dash. And this backslash, remember, is to escape the period. But we want to match on more than that, and probably the longest one is going to be smart. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters. So what we'll say is, let's match on any string of these, any repeating pattern of these characters between 2 and 10 characters long. So if a line begins with A through Z, a period, a dash, or a forward slash, and continues using those characters for up to 10 characters, then we'll match on that. 2 to 10 specifically. And the rest of the line we don't really care about. That's our first regular expression. We can test it. Let's test it. So what we'll do is, I wish the path wasn't so long. How about we do this? I'm going to say PS1 is equal to ... just to clear this out for you. That's a little bit cleaner. So we'll do grep. Let's only print out, and we'll use extended regular expressions just in case we need the fancier syntax, but we're only going to print out the matches. That's what the O does. And then if I now type out the regular expression, I'll type it. I'll end up copy pasting soon enough. And yeah, well, I mistyped it, but now all hell's breaking loose. So yeah, backslash period, forward slash, and a dash, and we want to match on 2 to 10 of those. So we've already explained like the syntax for this regular expression. Now we just need to point it at a file, which I've already forgotten the name of. I've forgotten the name of it. Tab. Oh, well, luckily there's only one file, so that was easy. We can tab complete. And let's see what it outputs. Well, that's promising already. We've got lots of capital letters I'm seeing. We've got IO, so we're matching on a forward slash as expected. We've got another IO. We're going to deduplicate toward the end. Radius, we've got PCIX, so that dash is working. And let's make sure that we got smart in here somewhere. I think yeah, there's smart. It's matched the full thing. So that's already looking pretty good. Cool. So we've verified this appears to be working. Well, is there anything else that we need to check? What you could do is if I get out of the way, we could grep it again. We could pipe it into rep, use the vertical pipe operator. And if we wanted to make sure like maybe TCP/IP is in there, we could grep for TCP. And there you go. TCP/IP is in that output. We've taken the output, redirected it back into another grep command and searched for TCP. And we got TCP/IP out. So it looks to be working. That's regular expression number one. Groovy. Next one. The next pattern we saw was it was uppercase, lowercase, uppercase, right? So it's something like this. It would be IAAS or IRDA, I believe was one. That's probably, yeah, that's probably enough examples. So how we match on that, it's going to be the same. Very similar syntax. It's just that we are going to also allow lowercase characters, a certain number of those. So we'll say uppercase, let's allow A through Z. Let's do 0 through 3, or you could just do, no, let's do 1 through 3. Let's do 1 through 3. So 1 through 3. So 1 to 3 uppercase characters start the line. That's what that caret at the beginning means. And then we'll do lowercase, A through Z. Let's do, what's the longest one I've seen? I think it's 2. We'll just like, we'll add a little bit of leeway, you know, just in case there's a few acronyms I haven't seen that have more. So if I've seen mainly 2, we'll say, let's do 1 through 4. 1 through 4, that's fine. And then it will end with uppercase 2, and there's like open. Okay, let's do 1 through 4 for that too. So once again, now we're uppercase characters. So it's a string though. It's like 1 to 3 uppercase, 1 to 4 lowercase, and then 1 to 4 uppercase, like this. All together. Yeah, it looks like the syntax. There we go. So beginning of the line, up to 3 uppercase, up to 4 or 1 to 4 lowercase, and then 1 to 4 uppercase. That's what we're matching on here. That should hit all of these. It's pretty flexible. And once again, we'll test these as we go. So you see how I'm like building this out? Eventually we're going to glue these all together into an OR condition so that it matches on each of them. It's like this one or this one or this one or this one for each line. But it's easier to build these out like piecemeal, right? And to do it more modularly, you know, basically break it into steps as opposed to try to write the whole thing in one line. Some people I'm sure can do that. I can't. So we will arrow back up. We're going to just replace the regular expression here. Paste in our new one. And that's looking promising. Look at all those mixed case acronyms that we have now. Perfect. Perfect. That's good. All right, that's that one verified. There's also lowercase characters that could begin, and now we can start copy pasting these. So we could begin a line, or we could begin the word with lowercase characters. Let's see. We have the caret to begin. And what do we want to start with? I've got the document over here. Why don't we do 1 to 4? Let's do 1 to 3. So we're going to say, I'm trying to interact with the video recording instead of the actual text editor. So we're going to start with up to 3 lowercase characters. And then we'll do maybe 1 to 4 uppercase characters, or I don't know. Yeah, let's just do that. Let's just do that. That should be fine. We'll test it. So it's not a big deal. So lowercase to uppercase. We did uppercase, lowercase, uppercase, lowercase to uppercase. there might be a smarter way to do this, but I like how it's flexible doing it this way. Like it can match on a lot of patterns, but it's also not so flexible that it's going to match on just regular words. It's like I think it's a nice middle ground actually. It's just not that it's not going to be pretty to read. I can guarantee that. Not when it's done. What would this match on? This would be like your expat, something like that, right? That looks good. Let's try it out. So again, I'm going to arrow up. Let's clear the screen. Arrow up, and we will Control A to go to the beginning of the line. Didn't really, I think that might have actually taken us more time versus going from the end, but whatever. And we will search for that. There we go. Yeah, so all these are beginning with lowercase characters. We've got eSATA, we've got expat, we've got iDRAC, we've got ILO, iSCSI. Groovy. Next, we want the reverse of this. So we want uppercase followed by the lowercase only. This would be like your IPsec, something like that. So we'll say uppercase is A through Z, 1 through 4. That's fine. And lowercase, let's just do the same. We'll do 1 through 4. Once again, we want to begin the line. So we want that caret at the beginning. That's called an anchor. It means the line starting right here. The line starts here. Right at the beginning of the line, we have to match this pattern. And we'll copy paste. My monitors are arranged kind of strangely, so I have to like look behind one to see the other. I'm not the best with the organizational stuff. Paste this in. That didn't match anything because look, you see, you didn't see the error because my head's in the way, kind of, but you see that? Now we've got like a double caret here. So you can't have two beginnings of a line on the same line. It's not going to match on anything. So I have to get rid of that, and then we should be able to get it to work. So if I get rid of that second caret slash hat slash whatever you'd like to call it, there we go. Now we see there are a few things that are getting matched here that I don't like. I don't like that inexpensive is getting matched and like all these others. The reason being we're starting with uppercase and we're going to lowercase. So what we could do, I'm thinking what we could do is let's do a space. Let's do a space. So I'm gonna just add a \s, and that means there has to be a space after these up to 8 characters. There has to be a space. So if there's not a space, if it's another character after we've matched this pattern, then it's not going to match. So let's try that instead. I'm not going to paste it. I'm just going to do a \s. And that's looking better, right? That's looking better. I mean, there's test, but whatever. It's not gonna destroy the dictionary of acronyms. The word test. Cool. And we'll make some space for my giant letters here. What else do we have? We also have, there are some terms that have dashes, but I think we got those, right? No, yeah, we did. We got those with this. Okay, so that's good. That would be like your IS-IS, intermediate system. You know, it's a routing protocol. We already got those. So the last one that comes to mind is uppercase letters followed by numerics, right? So your FAT16, 32, things like that. It could be EXT3. And what we'll do is match on those. And really all of these should have this this space after them, but don't. We'll see. I'm going to include a space after all of them in one go when we glue them together. Let's do the final of these regular expression building blocks that we're going to glue together, and that would be for our FAT32s, this type of stuff. Or another one would be AES, like 128. So you're probably getting the hang of this by now, but it would be we're beginning the line with A through Z, capital letters. We want maybe 4 of them, 1 to 4, let's say. Let's say 1 to 4. Let's say 2 to 4. I'm trying to like search my memory for like all the different things I've seen, right? So we'll say 2 to 4, uppercase characters, and then we'll say 1 to 3 numerics. So 1 to 3, or excuse me, 0 through 9 are the characters we want, of which we want 1 to 3, right? 1 to, 3. So we can have 2 to 4 uppercase characters, A through Z, and then 1 to 3, numeric values, 0 through 9, digits. Let's test that. As is tradition, let's clear the screen and let's just take a look here. Should be good. I think that's good. First glance, it looks okay to me. Yep. So we got MD5. We've got probably SHA-256 in here, or we should. Did you not? Yeah, well, there's AES-256. They don't mention SHA-256 anywhere? I might be missing it. Who knows? But there we go. Okay. We've got all these now, all these building blocks defined, but we want to match on all of them. So how does that work? Well, there is a syntax in Bash for doing exactly that. And in Bash, not really, in grep is the proper way to say that. In regular expressions more generally. And the syntax looks like this. So it's a just parentheses with these vertical pipe operators. Those mean or. So essentially, when we have these vertical pipe operators, we're saying either A or B or C or D or E, or you get the idea. So we're going to take each of these and we're going to make them one of those letters. We're going to be, it's going to be either this regular expression, this one, this one, this one, or this one. But there's one thing I want to change here. We don't want the anchor. We don't want the anchor within these OR conditions because they all start with it. So we'll take the anchor out for that. And what we're going to do is put it at the beginning of that OR condition. So it'll look like this. Anchor, parentheses, followed by every single one of these. So let me just do, I think 4 is enough. And we'll copy paste all this in. It's so elegant. There's definitely a more elegant way to do this. I guarantee there is. But there's a trade-off between elegance and the amount of time that you want to spend on these things. Make sure I'm getting all the syntax. I'm double checking the syntax as I go. You know, it's easy to miss a character, accidentally delete one or overwrite one. Looks good. And we've got our final one here. Cool. So we're now matching on all of these. You know, the line has to begin with one of these. And then the last thing we'll do is a space at the end. This is saying, well, there has to be a space after that. So it can't like continue on with more letters. Otherwise we match on longer words. All right. All right, let's do it. Moment of truth. I really hope the syntax is right. Otherwise, this might take some troubleshooting with a regular expression this long. What I would do if there's an issue is I'd break it in half, try the first complement of these matching expressions, then the second one. Yeah, basically try to break it down, go in the reverse direction and see if I can identify where the syntax issue is. Clear the screen, we'll arrow up. Now we were already using OE. Just to remind you, O is only printing out matches. It doesn't print out like the entire line, but just the match. By default, grep's going to print the entire line that a match occurs on. And then E means we can get fancy with it. And what we'll do is just arrow, arrow, arrow. I'm going to delete all this. And I think we're good. So let's try it. Let's go. Okay, let's see. Okay, I'm seeing lots of uppercase. Well, first off, we didn't get an error, so that's promising. Yep, there's lowercase. That's one pattern. That's another pattern we had. iDRAC, that beginning with lowercase. iSCSI beginning with lowercase. Cool. Looks like we're catching everything that I wanted. CAPTCHA. Okay, smart. Cool. It's looking promising. Did it catch? Let's do, what I'm going to do is right here. I'm going to pipe it into another grep and just search for a few of these to make sure that we're matching them. Let's say grep for fat. And there they are. So we're taking that output that we just generated and we're searching through that now when we pipe it into another grep command. So we've got those. It's looking good to me. Now let's take a look at this. I'm going to arrow up. We got this full command, and that prints out everything just to the console. But first off, like I said, there's a lot of duplication that occurs here. So we want to deduplicate, and that's easy enough. So what I'm going to do is use the sort command. I'm going to pipe it into the sort command. So instead of printing it to the console, we're going to redirect it into another command, which is called sort, if I could type it properly. And we're going to use this -u flag. So we're going to put it in order, And then we're going to only keep one of each entry. So they have to be unique is what I'm trying to say. So it will deduplicate these entries. Now let's do that. Wonderful. Now let's see if I can find a duplicate entry still. Whoops. Maybe I'll get lucky, but usually there's like a space or something that causes these to be duplicated. Even maybe I'm just that good. I don't see any duplicates. What I wanted to show you is this. Sometimes there'll be like a space, you can't see it, but it still makes the line different. So what you may need to do occasionally is you'd use like you could use like a sed command, for instance, for trailing spaces. It would be like a sed. You'd want to substitute. We saw the beginning of the line anchor, that's a caret. The end of the line anchor is a $sign. So what you'd say is, for any space at the end of a line, we want to just substitute that with nothing. That's all this is. Not going to, apparently it's not going to change anything for us because we're perfect. We did it perfectly the first time, as usual. We're awesome. All right, last thing I want to show you, I'm going to redirect this into a file momentarily, but last thing I want to show you before that is you can check this as you go when you're working with regular expressions and text filtering like this. What you could do like as a quick sanity check, let's imagine let's go this is going to be the pre-sort, pre-deduplication step. We're going to pipe it into WC, which counts words and lines, and we're going to count the number of lines here. How many lines are in this file? Without the deduplication, 1,246. Now if we pipe it into sort, unique, and then do this word count command, we should see far fewer actually. Notice how many duplicates there were, in aggregate. So now there's 508. So there were a lot of duplicate terms in there, and now we've distilled it down to just one acronym, not multiples of the same acronym in this dictionary that I'm building. So we will, having done that, let's just redirect it. You can redirect it into a file a few ways. And why am I doing it like this? Why don't I just move this over? Why have I been doing limbo this whole time? It's insane. It's insane. So you can just redirect it into a file. There's two ways to do it. You can either overwrite existing files or you can append to those files. So this is the greater than sign. A single greater than sign is going to just overwrite the file if it exists. So that's fine. It's just that you might lose data if you're trying to continually add to it. And then the double is going to append. So usually that's going to be a safer operation because it's not going to overwrite existing data. And we'll just call this CompTIA glossary cleaned. CompTIA glossary acronyms clean.txt. You could do like a less, and let's just look at our work here. Scroll on down. It's not too bad. 500, it was actually less than I expected, but that does make sense. Like CompTIA, they're kind of, a lot of the material they cover is at a certain level or range of skill levels. And it looks like they actually have pretty good coverage of a lot of different topics here anyway. So 500 is pretty good. A lot of these I've already had issues with transcription models like Whisper, so it's going to be useful. And there's other, like I said, there are other good sources out there. There's like NIST. Let me do NIST. Let's do a new tab and we'll search for NIST glossary. Glossary, whichever. And now the NIST glossary, I'm going to pull from this. I'm going to have to use a different mechanism. Excuse me, can you open please? Or what? Did the internet just die on me? The NIST glossary come on. Is that really? Okay. Let's see. Can we get the CISA glossary? Or is the internet just actually down? Okay, the internet's working. There we go. So this not actually, I don't know if there's going to be interest in this, but if you want to work with data in other forms, the NIST cybersecurity glossary, if we go to A, I think it'll show it. or it's somewhere in here. Yeah, so you can actually download it as JSON and you can parse the JSON. So we could demonstrate that if you want. And really what we'd be doing is going through this huge JSON document and extracting all of the terms and acronyms that might trip up a language, a transcription model. That's one option. We could do some JSON parsing. Alternatively, we could over on Nix. This is CISA, their glossary. Well, they've got a glossary of all these cybersecurity terms, pretty decent amount. How would we get all these out? We could copy paste, we could do that, but actually what we could use is something called Beautiful Soup 4. It's a Python library. And if I just show you really quickly, if we do an inspect elements, these are all these terms are contained within a specific tag. It might be hard to see. I wish I could make it larger, but the tag is DT. So each of these bolded terms is tagged with DT. So we could use a library like Beautiful Soup. We'd use requests. We download the page containing the full glossary. Beautiful Soup would then parse that page, and we could use it to extract everything between these DT tags. So just to show you what that it's like for spam, it would be DT, spam, DT. We could use Beautiful Soup to get this out and add it to our growing like dictionary. Other sources are the glossaries from PDFs and books. I think a really good source is like the awesome lists on GitHub. There's so many tools with weird names that would trip up a transcription model. So that I'm definitely going to add, and I've been working on as well. Oh, there's lots. Now they all have unique challenges. That there's like matching challenges depending on the data format and what you're going for. It's a lot easier if you're just getting acronyms like we are in this video. It's a little bit more complex when you get to weird names that tools have in IT, because there's so much variety and purposeful misspellings and weird punctuation and capitalization. So it does get more complex than this, but even this is pretty complex. Anyway, I don't know if that's even if that was helpful. I hope it was. That's how I build larger regular expressions for text processing. If it's helpful, good. If it wasn't, you can I don't know, eviscerate me in the comments. Go for it. Go for it. We'll end with that. If you are interested in any of these other types of text processing or extraction or scraping, just let me know. We'll do it. I take requests. So I'm gonna leave it there. Bye. I said bye too soon. Bye.